Okay, thank you. First, the talk slide is linked from the summary page here. So if you go down, it says on GitHub, which is the original discussion that we had. And this submission is what leads you to the actual slide. I have just one, and it's a vertical one. So the basic idea is we have a 40-minute slot. I plan to talk for about 25, 30 minutes. But since we're not a large group, we can make it more interactive. Like if there is a question or a comment that comes up in your mind, just say it or, well, raise your hand maybe beforehand, and then we can have a discussion. I don't intend this to be a monologue. I actually came here with a set of questions more than something to teach. But nonetheless, I do have a plan on how it could go, right? So the title is Post-Publication Peer Review of Jupyter Notebooks Referenced in Articles on PubMed Central. Because maybe not everybody is familiar with all those terms, let me briefly go through them. Post-publication peer review means that some scholarly work has been made public and we look at it afterwards and try to assess its value. This is actually something that happens a lot, but usually not in public. And so here we're doing it in public. A Jupyter Notebook, by now everybody in the room should know, but to those who may be coming in through the video later on, it's an interactive document with code, data, and text embedded. And it was nicely summarized yesterday by Zach, who is in the room. To a non-coder, a Jupyter Notebook is an interactive data document that happens to have some code in it, and possibly also some text. And PubMed Central is the largest repository of full texts published biomedical papers, currently on the order of 4 million articles. So we're going to go through PubMed Central, check the articles in there as to whether they have Jupyter Notebooks associated with them, and we'll have a look at how that goes. That's the basic idea. I have included a new section into the talk, which is basically reactions to other talks, because, well, we're in the final stretches of the conference and many other people have talked about different aspects that are relevant to this one. So let me just briefly go through some of those. First one is Fernando, in his opening speech, spoke about how he came from interactive Python to open science. And I'm basically coming the other way around. And that has certain implications. Then he also said science is about opening up the black box of nature. We shouldn't be doing that with things which themselves are not legally allowed. We are not legally allowed to understand. But if we cross out the legally and think about technically, it's still a valid statement. That's kind of the point we're going to make here today. And then, well, we have heard that Jupyter Notebooks can be used to share analytical workflows. So just from this morning, Jupyter as a conversational medium in science enabling reproducibility. And there was an earlier presentation in this room yesterday, and it was actually demoed. Has everybody in the room here seen how my binder works? Who has not seen it? Okay, well then we don't need to demo it again, the link is here. Then it can also be used in data journalism, for instance. The point here is just to share analytical workflows, and this can happen anyway. It can also happen in industry. There have been separate talks on this, but I couldn't go to any of those because there were too many things happening in parallel. Then they can also provide a great learning experience. Lorena called it the killer app for education this morning. I like that a lot. The big problem is it only works when they actually run. Right, and here we have to zoom in a little bit. Then Jupyter Notebooks have begun to be shared along with scholarly publications. So earlier today there was a talk where they were referring to an earlier study in which they found that in a large database for astrophysical papers, they found 91 papers that actually had Jupyter Notebooks attached to them. They did not look as to whether those notebooks actually ran. They just looked at how the notebooks were mentioned or cited. Yeah, so here's the link to that earlier presentation. And at the time, which was someone last year, we had a similar number to those 91 also in PubMed Central. So across disciplines, we're talking about similar orders of magnitude. Another aspect that kind of resonates with Fernando's remark, data science is a critical skill for today's engaged citizen, is that Jupyter notebooks have begun to be shared on Wikimedia platforms, and I've included an example here. Let's actually have a look at this one because we haven't seen much of that here. So we are in a Wikipedia article about what is this Lambert series, right? And it references here number 1, a Jupyter notebook. You can actually go there, and it gives you the NB viewer version of it, and then you can see basically where this figure came from and so on. And I think we could have much more of that, especially if the notebooks could actually still be run and would still produce the same figure. Then, yeah, the same applies to Wikimedia Commons and other examples. So here, again, they link to the NB viewer version of the notebook that has been used to create that particular video. And another thing that came up this morning, reproducibility is not a one-click solution. And here, actually, I think I would actually tend to disagree if it's written as broadly as it is. So Lorena said it this morning, had a dedicated slide to this, but I think what she meant is the research reproducibility, because you have made the distinction to the computational reproducibility earlier in your reference to Claerbout. And so I would say we should strive for computational reproducibility to be a one-click solution, and then the research reproducibility is indeed a conversation to have, and the Jupyter notebooks can facilitate that conversation. So now, where does the inspiration for our project come from? So we have places like try.jupyter.org where you can go and see a notebook and it actually runs quickly. Problem for me as a researcher is the examples given there are irrelevant to me. And so what I would like to do is take notebooks that are shared with papers in my areas of interest and run those. I would learn much more from those notebooks. The problem is these papers or those notebooks, they're really relevant, but I can't easily get them to run as someone who's not a proficient, well, I'm a beginner in terms of Jupyter and Python. And also, even if I often know how to fix those things, I don't want to spend all the time in terms of fixing all those dependencies for a notebook whose value I cannot even know beforehand. So the point here is to make that simpler. And another thing is, I have been involved in other kinds of validation, for instance, of XML trees, for which there are tools like Schematron that allow you basically to throw your XML at the tool, and then it will tell you whether you're conforming to that particular standard or not. And it would be nice to have something similar. Maybe that's a bit naive for something as complex as Jupyter notebooks, but at least as an inspiration, I think that's a valid starting point. So when was it? In March, Open Data Day, I helped co-organize a hackathon, and amongst the ideas that were pitched at the hackathon was the idea to actually go through all the Jupyter notebooks mentioned in PubMed Central. And so that started a thread in GitHub, and in the repo for that particular hackathon. So here you see I actually started the thread a few days earlier, and some people actually chimed in already earlier before the day. So at that time we had, if we just search for the phrase IPyNB or Jupyter in PubMed Central, now we get 164 results. At that time we got 102. So that is just half a year ago, and we have 50% increase for that same search. That means also that it's about the right time to discuss standardization. It's not a lot happening yet, but it's increasing fast. And yeah, you can also, of course, add some more search terms, like, for instance, Python, but I haven't done that initially because it produces more, let's say, false positives, where people just refer to IPython as a general concept rather than a notebook. And so if we just constrain ourselves to using IPyNB, that actually gives the highest rate of hits, but Jupyter is also not too bad. And yeah, so we basically first had a problem to identify those papers where you actually had notebooks in there. And that is still a problem that I don't know of a good automated solution for. Because, as we will see, and as we also heard in an the earlier session where they were looking at how the notebooks are cited, people are citing them in many different ways. I actually have some examples here. So from that paper where they found those 91 papers in the astronomical database that had Jupyter notebooks associated with them, they found that 37 actually linked to openly accessible Jupyter notebooks, and others mentioned, 54 of those papers mentioned Jupyter somewhere, but don't really link anywhere. And then even if they link, there are multiple ways in which you could do that. You could link to, let's say, the NB viewer version of your file. You could link to the file as it sits in your GitHub repo. You could link to the directory in your GitHub repo that contains the notebook. Or you could just link to the repo that contains the notebook. And all of these things are being done, and there are a few variations, like when people actually have a copy of their GitHub account archived on Zenodo, they might link to Zenodo. So there's lots of ways, and sometimes people just give the file name and mention somewhere in free text that it sits in a GitHub repo. So right now, this is something we can't easily address by text mining or so. There's no tool, so we really need humans to go through that, which we actually did. So we had a spreadsheet. I can probably show that. Here we go. Someone just created a spreadsheet that we could actually use during a hackathon to annotate those things. So what the spreadsheet contained was the URL of the paper, the title, and then an attempt to find some URL for the notebook. And in the problem cell, we were recording basically the first error that popped up. We never went beyond the first error, except for one notebook where we really tried to fix all the errors so that we could see like how things get more specific over time, and then also comments. The color actually tells you already much of the outputs. Out of those 25 notebooks that we tested during the hackathon, only one ran through. Yeah, which was really surprising. As I'm a learner of Jupyter, I was hoping that there would be like 90% or so go through so that I have a larger variety to choose from. The one that actually ran through is a very simple one. Very simple. It basically has no dependencies. And the problem with the dependencies... Yes. And the problem with the others which have dependencies is often they're just expressed in like human readable terms. They tell you, well, you would have to install this and that. But for instance, many of those notebooks or repos don't make use of requirements text or things like that. And and also versioning is not indicated. Sometimes even the kernel number is not indicated. So you don't know whether you have to use Python 2 or 3 or something else. So yeah, so this is our initial like attempt. And after those 25, we actually stopped and took a step back and tried to communicate. Also, the hackathon then ended, basically. And this was a spare time project. And we just then focused on trying to find others who are active in this space. Because, well, for me, this was kind of new. I had assumed that at least for things like Jupyter Notebooks, the rate would be higher. And even for, we also found for some things that actually came with a Docker container or even in MyBinder, even those did not always work, typically because data dependencies were not taken into account. So MyBinder is very good for software dependencies, but it doesn't take into account data dependencies very much. And so that is, well, food for thought. And actually what was interesting then is that well, the hackathon ended on March 4, so actually, yeah, we then closed the ticket here, basically. No, on March 5, it was a 2-day hackathon, actually. And so at the end of the second day, this person who was part of the team who was initially looking into this wrote up a nice blog post, which I should perhaps show, because it describes what we have actually done. So that would be the methods section if we were to put this into a paper. And it also comes up with a number of recommendations. So yeah, so some of them I already mentioned. The dependencies are a problem. Also, the Jupyter notebooks are very versatile or they allow you to be very, let's say, promiscuous in your usage of programming languages. So if there is a certain thing that you just want to do in shell, and I'm doing this all the time because I'm much more comfortable doing shell scripts than Python. So for small things, I just use the shell, either directly or sometimes in a notebook. But this makes assumptions about the underlying operating system, which then makes it harder to actually rerun that particular part of the notebook. And yeah, some older versions actually did not indicate the version of Python that was relevant. Or some others actually assumed that there was Java installed on the computer, things like that. And all of that is not easily expressible in a way that the machine can understand, so that we can automatically run and validate those notebooks. So with the experience from that largely read spreadsheet, we then thought about mechanisms by which we could actually automatically validate certain things as to whether there's any error in processing that script, and then maybe also start to classifying the errors. So we now actually do have some prototypes for notebook verification. Let me briefly show them to you. So one of them makes use of continuous integration. Travis, that's a concept that I only understand vaguely. I think it is used in complex software development projects all the time. And so I have the hunch that this approach might be very useful in actually addressing some of those issues, but I don't fully understand how it works, and I couldn't get this tool to run for me. But what it does is, or at least what it says on the cover, is that you can throw an individual notebook at it, and it will then tell you whether that notebook runs through. And it has a little lower barrier to entry, in the sense that things that are part of the scikit, let's say, bundle of libraries, are already pre-installed on that machine on which we're testing. So if anything is not properly declared but part of that scikit, then it will still run, which in our, let's say, hand manual testing wouldn't have been the case. The other environment or testing tool that we have is actually a Jupyter notebook. Yeah, actually would love to have an analysis of all those Jupyter notebooks actually run in a Jupyter notebook that is shared reproducibly. We are not there yet. If you can help us do this, then that would be welcome. So what this one does is actually it goes through the notebooks that we have listed in our spreadsheet, and then runs them one by one and documents the errors. And the last one is, let's say, the most actionable one. The code was actually published just today. So what we have here is a web app that can take some input. So for instance, let me just throw these lines here. So basically URLs to papers. And then it starts analyzing them. It will take a minute because it downloads them, tries to run them, tries to install the dependencies that are properly declared, and then it makes a judgment as to whether it actually ran through, and it will give you the output and things like that. So this might take a minute or so. We can get back to it later. So the discussion, as I mentioned, then drew a lot of people who actually were not at the hackathon, which I found interesting. So well, initially you see a lot of me, and this is actually also the list of the notebooks that we have extracted. And then come in people here. Tom Pollard was not at the hackathon, and Jan Gander was not there. Schmeling was not here. Ketch was not there. And somehow this drifted outwards, and people came in who sometimes have thought about these issues much more deeply than I ever did. And so turns out, yes, there are papers on the topic which focus on specific aspects of the reproducibility, not actually on Jupyter, but more broadly for software. But some of the concepts are applicable to Jupyter as well. Just not necessarily by me, because much of it, the discussion is actually beyond me. And so some of the arguments here in that ticket, I don't fully understand. Yeah, and by now we have 80 comments in that GitHub ticket, which we have also used to actually organize the submission here to PyCon, to JupyterCon. At some point we thought, well, why not just get it out here to get some feedback and to link up with others who are doing these kind of things. Let's see, yeah. No, this one is still thinking. So Panda is installed. Yeah, you see it's working on all those dependencies. And yeah, people also came in and posted stuff that they had done. So for instance, here, Catch, I don't know who that is, says they're writing a book on Jupyter Notebooks, and they're actually testing that all notebooks run without errors in Python 2 and 3. And so here's a link to that repo, which is very much aligned in spirit with what we have been trying to achieve. Then, yeah, other such things also popped up. Another thing I should mention is there is a concept called the software citation principles. And that relates a bit to the previous talk where they were looking at how the Jupyter notebooks are being cited. And the software citation principles, they don't make specific recommendations for things like interactive things like notebooks. They are kind of mentioned, but it's not entirely clear. And the point that I think should be thought about a little more is actually to what extent you should be citing a container in addition to just the notebook itself. So maybe the solution, so in the software citation principles, I actually had wanted to include that in the slide, but for some reason I haven't. They say at some point, if there are multiple versions of the software, like it exists as source code and as something else like a binary or so, you should always go to the source code. I think that's right. But the way this was written actually implies you should only cite the source code, and I think we should broaden this a little bit to say you should always cite the source code, and if possible, add like a containerized version or so, so that you can actually run the code and people have other ways to interact with it. So here, the report has now run through. And so here we have the list of our papers. It has gone to the paper URL. For the first one, it hasn't found a notebook. For the second, it has found a notebook. We can look at the notebook URL. We can look at the let's just go at the output. So yeah, that's basically the output of that particular notebook. And yeah, it's failed false. It didn't fail. We now kind of express it in a double negative because like expressing it in positive would just work too rarely. So our assumption is now that it will be false. But there are some that actually, for which failing is still true. So those that I just chose here, they actually, I chose on purpose such that you would see one for which it's false and for which it's true. The problems that this tool still has are actually multiple. So as I said, the code was posted today, so it's really fresh. For instance, it can't distinguish between things that are just mentioned as NBView or in a GitHub repo or things like that. We also have cases where the notebook is enclosed in a zip file. I also have some other cases as a figure only or as a PDF attachment. A notebook, an interactive notebook being shared this way. Just talking about this gives me shivers. But people do it probably because either the publisher imposed certain restrictions or they thought that the publisher would. And so they didn't share the interactive notebook. They just shared the screenshot or a PDF. Yeah, well, you can look at those examples. They're linked. And yeah, sometimes it's in a zip or in a tar file or something like this. And all of these things are too complex for the tool right now. But these are things that we have to take into account if we want to basically monitor that landscape. So what we want to get to then in the long run is something like an idea as to how we could structure some recommendations in terms of how people should share their Jupyter notebooks along with papers. as long as we still do papers, or even how they should be shared standalone. And for that, some generic recommendations are that the dependencies really have to be made explicit and in a machine actionable way. So if you start with requirements.txt for Python, that is a good start. It probably doesn't solve everything. Specifically, it doesn't handle data very well. But it's a good start. In other languages, like R, there is not an easy equivalent to requirements.txt, so it's a bit more complex. But this kind of ties into the discussions that we had about the data frames in one of the keynotes yesterday. So data frames are handled differently in the different languages, and we kind of need ways for them to interact. Jupyter could be the way to help bridge that gap. And maybe we need something as well for declaring those dependencies. These apply to libraries in the notebook's main language. Like if it's Python, then all the Python libraries should be properly declared. It also applies to libraries in other language or to generic code. Like Bash is a key example. It's often used in those notebooks that are actually shared. It should also apply to the data sets required by the code and to dependencies for all of the above. And some of them might actually be very deep. So in one of the workshop or tutorials on, when was it, Wednesday, we were installing lots and lots of things for nice visualizations. And at some point, not entirely surprisingly, they asked me for GCC to install, which I don't have on my machine, which I didn't really expect when we were installing Python. But of course, they were showing some things that were very rapid computations, and I was wondering how they would do it in Python. Well, and under the hood, like once you've installed like 20 or 30 of those libraries, then you notice, well, you also have to do GCC, and this wasn't part of. They had a tool that would actually like validate whether your system is ready, and it didn't flag that. So even if they were prepared, they didn't show this dependency. And in general, like there is a note of caution in terms of like data dependency. So for instance, you could say, well, if we want to get rid of data dependencies, then we just go for containers and we put all the data that we need into the container and then we're fine. But so here's a note of caution. I live in a world where datasets are a few gigabytes in size and processing requires a few hours, and possible parallel computers. And these machines often have network restrictions that make downloading data from the internet impossible. So if it's multiple gigabyte that you want to encapsulate in your container, and then you might run into storage problems and things like that. But if you do not encapsulate that, then for certain applications, you just can't make use of the data because there is a firewall or something in between. And so it may well be that there is no single one optimal approach to solving this, but we have to think about those issues in a more systematic fashion. Yeah, and so the last line here, there's too much diversity in scientific computing is probably something that we really have to take into our heart. And then there are side effects that popped up, like if people, for instance, have released a version of their software to Zenodo, then they have a DOI, nice identifier that facilitates citations, but it's not necessarily easy to kind of use that identifier to actually point to the notebook within that repository. And so there are discussions around that, how you could facilitate these kinds of things. And there are separate discussions on data citation, which interfere to some extent with the software citation things. And right now, both of those efforts are basically concerned with getting the basics right, like getting citations to normal software more organized. And then Jupyter doesn't really count as normal software here because of its interactivity and things like that. Okay, so there are lots of open questions, many of which I've already mentioned, but let's summarize here a little bit. So to what extent can we reuse existing infrastructure, like continuous integration or some of the other tools that the people who write the books in Jupyter also are using? To what extent can we reuse that for the purpose of validating a given notebook, or a particular version of it, let's say a containerized version. What standards exist or are emerging in terms of best practices for mentioning notebooks, citing notebooks in the sense of a scientific reference, bibliography, or expressing dependencies, documenting also when a validation was run. There are certain timestamp routines or magic commands that you can do in order to indicate like when a notebook was run. And we could think of a system where you validate several times in the process. For instance, before submissions, the author could validate their notebook. During the reviewer could validate their notebook, and then there could be a timestamp associated with that. And upon publication, ideally shortly before, the publisher would validate that it still runs and still basically produces the same output, things like that. Right now, we don't have this, but we need to think in those directions. And then Outlook, basically coming back to the things that I mentioned in the motivation part. So we want to be using Jupyter notebooks for research. We want them to be used to democratize access to data science for everyone, as Fernando put it. But there are also, yeah, and Wikimedia would be a nice example for that. There are side effects to this, or let's say related avenues. So for instance, Colibri is a tool that helps you prepare content for offline use. Just last week I was at a hackathon where we basically were concerned with getting Wikipedia and related content like OpenStreetMap packaged into a tool called Internet in a Box that can then be deployed in areas where there is no internet, be it underdeveloped countries or be it areas that just had a major catastrophe or something like this. And so far, in those kits in the Internet in the Box, they haven't included things like Jupyter notebooks, but in principle, they could, especially if we were better in figuring out the dependencies and making sure that they will actually run, because these things, they are off the Internet. They provide you with a local Wi-Fi hotspot that is not necessarily linked to the large web. And yeah, data journalism is another area where I think these kind of validations could come in handy. Like if a certain notebook has been, let's say, verified by the New York Times or something like this, that is maybe some indicator of quality. And maybe better than if it's just verified by me or something like this. And so we have actually tried to run some of those BuzzFeed examples through the analyzer tool, and right now they're not being picked up because the tool basically only understands papers for the moment, and not if you put a GitHub repo at it directly. And yeah, we're looking for partners to help us pilot potential solutions to these problems. And here is my contact info. So now I hope that we can have some discussion. Well, it's Friday afternoon, I understand.
Yeah. Given your initial sort of trial run that you ran with these, I saw that a bunch of those errors as they appeared were sort of the standard Python 2, Python 3 problems, and those are obviously going to remain problems at least until, I guess, 2022 or something, until that's all behind us. And the same would generally apply for, for other classes of these incompatible libraries. So I think we as a community have to sort of come up with some, if we're going to test these things in some order-of fashion, what do we regard as our matrix that we want to use? Do you have sort of opinions on that yet?
Yeah.
Because we can't test everything.
Yeah, I think we should probably come up with some reasonable prioritization. First thing is decisions as to whether we should test in an entirely naked environment or whether we should make allowances like the scikit approach, That's one thing. Then we could basically say we ignore things that are older than 5 years or so, which covers most of those cases where the kernel was not identifiable. Yes, we have to make certain, let's say, decisions, and common sense is probably good. My common sense for this might not be the best one because I'm not familiar enough with those issues, but some of the other people who have thought more about this probably have a better handle on this. And also, I think it could be fine to just really try to run the analysis for larger amounts of such papers, like if we include the IPython in the query, or if we combine the PubMed sample with the astronomical data set, then we are in the order of several hundreds of papers that potentially have notebooks associated with them. And some of them actually have multiple notebooks, which we're also in the process of now picking up. So the tool that I've demoed actually can understand if there are multiple notebooks associated with a paper. Yeah, so these are the parameters we have to think about. We don't have anything prepared yet that could serve as guidelines, but I think coming up with something like 10 simple rules for sharing Jupyter notebooks in a reproducible way would be nice.
Another question is, given that you found these notebooks that are public and linked to papers that are, for lack of a better term, broken, have you reached out to these authors or the accompanying Git repositories to correct those?
I've reached out to 1 or 2 of them, and they then also joined the conversation. Okay. But yeah, well, the scale. This is a spare time thing on top of the other spare time activities and real life. So no, we haven't done this systematically, although in theory we could, because these are full text databases. So in theory there is one email associated with each of these papers, at least one email. Some of those emails won't work anymore, but some of them will. So that's, and since the text is available in XML, you could just scrape that and then send some mass email to the people. On the other hand, I'm not so sure what that email should contain, because if you just tell people, look, like especially if you do it in a generic way, look, we have this generic problem and your paper is part of that generic problem, it's likely to be ignored. In order to be, for these emails to be effective, you really have to show them, look, there is this error with your paper and or with your notebook, and that you really should think about fixing this. And then many of those things are actually not as, let's say, problematic. Many of those things are just missing libraries that are, even for a novice, more or less simple to install. It's just the problem that the dependencies are not declared, and so it will not run through at the first attempt. And we just didn't have the time to do a second attempt. So we could also think about having a certain arrangement of attempts. Like first one, we just give it a simple pass, as we have done. Second, we try to install all those dependencies that can be inferred from commands like import so-and-so. And then if we run into, if we've done that, and the next layer of problems is then more specific and will need, let's say, different approaches. But we haven't done that. We've done it actually for one paper, which had a Docker container with it, and had, well, let me see whether I can bring that up. So we went for both breadth and depth. So depth we did for one paper, and breadth for like those 25. So here in the initial, so yeah, here. So some authors have taken the laudable approach and extra effort of bundling their notebooks inside containers, typically using Docker. This is very effective. This is also the approach taken by the complex notebook that we analyzed in depth, where we tried to fix the errors as they came in. And here you have cases like the container was not immediately rebuildable due to a missing file. So this particular zip file was missing in the Docker container. And well, it wasn't obvious from the requirements that this would actually be needed, and it wasn't obvious where to find it, so you had to Google around, and then finally we could find it. Things like that. it's a complex matter. Are any of you in a position to help us like move this forward, fix this? Do you know of any tool that could help validate it? Do you know of any set of standards that could be used in terms of how dependencies should be declared within Python, like making the requirements text, let's say, more standardized, or applying this approach to other languages, things like that? That's the kind of things we would be looking forward to know more about.
So I do believe that there have been several discussions in the Jupyter notebook community around additional metadata in notebooks, specifying more detailed things around dependencies. Dependencies is really hard.
Yeah.
So the LIGO,
yeah.
they've let their notebooks freely available. I think that people have posted them on Azure notebooks, which is just notebooks on Azure.
Yeah, I actually used the LIGO example lots in other presentations I give. Right now, it doesn't work because binder is broken. The beta binder.
It's hosted on Azure as well.
Okay. Who has them?
Min, he, if you, I think it's MRK. Sorry, MinRK. Yeah, MinRK. On GitHub, he has a binder working with the new beta version of Binder that's actually out now.
Would be nice if you could send that to me by Twitter or just post it here on GitHub or so.
I think that's additionally nice about that is that it's a hosted running instance, so you don't need a browser, you don't have to download it to your own laptop.
Yeah, well, and it's actually one that I went through. It's one of the first notebooks I actually went through, and that kind of helped me get inspiration for this hackathon task. So I was in the room when they actually announced this finding with the LIGO. I was excited. It's not my field, but I was excited. And the documentation was really good that even if you were not in the field, you could make sense of it. And so I spent like 2 afternoons or so in that particular notebook. And then I was wondering, well, why don't people do this more often? And in my fields. And then I went to PubMed Central and looked for like papers with notebooks, and I discovered, oh, they're actually trying to do it. And then I ran the first few ones on my own. Didn't work. So I thought, well, I probably need assistance, and that's how this hackathon project came about.
I think that it might be worth sort of stopping by the Jupyter sort of sprints tomorrow.
I'll be in the air then, can't do this. I actually have to go directly after the session. Yeah, also I didn't know about those sprints early enough. Yeah. Yeah.
Thanks a lot.
Lorena.
Certainly, it should be best practice to make the effort to include and document all the dependencies for a notebook that is meant to be supplementary material to publication. But on the other hand, I am ambivalent about this idea that you should require all notebooks to be automatically run and without the intervention of the user and without asking the user to take some responsibility for interacting with. I mean, there's a degree to which this is overkill, because it is not too much to ask of the user to interpret an error message that is indicating a lacking dependency and go fetch that dependency and install it. It's not a big deal, I think. And requiring this level of automation where the notebooks are run from just one command without you even looking at them is going to be excessive in many cases. We work with notebooks, we've been working with notebooks for years, we use them in our research flow every day, every single of my students in every project. And we have streamlined our process to make sure that there's always an environment like YAML, that we're very careful about documenting dependencies. But at the end of the day, it is the responsibility of the author to provide that, and it is also the responsibility of the reader or user to do a little bit of work. And that's my ambivalence here. Because on the one hand, for example, with containers, right? If we really move to a fully containerized solution for reproducibility, what I fear is we're going to start hiding all the bad habits into a container. People are going to start putting all their bad code into a container because it doesn't matter. You just run the thing. Nobody has to touch it or see it. And I don't like that. I want to see computational scientists developing the skills that are required to write good code that is comprehensible, readable, testable, and all of that. And in addition, you can put in that container to facilitate things, but not just dump your bad code in a container because nobody's going to look at it. So in a way, I feel like similar. So this is an analogy, right? So I feel technology takes it to an extreme where we take the responsibility away from the scientist, both author and user, to do the due diligence and do a little bit of work when it is required to comprehend, execute, and then build on the work that is being shared with them.
Yeah, I see the same, let's say, tension, but things like the scikit approach or so, they can help address that to some extent. So basically you could say, well, I assume that those kind of packages will always be around because we make a lot of use of them. There may be cases where we actually do need the user to actually do stuff, and I agree that is not always avoidable. On the other hand, Zach gave a talk yesterday, and there are extensions that actually explicitly hide the code if you're talking to a non-coder audience. And that is, in biology, that's often the case. People will run away, or if you show a Jupyter notebook with code to physicians, many of them will just run away. And and if you ask them to install a dependency,
yes, it depends on your audience.
yeah, and so if we want Jupyter to reach out to new audiences, we have to keep that in mind.